Welcome to my video for special exponents. We're going to talk about what it means to have negative exponents and what it means to have 0 as an exponent. If you haven't already, please pause this video now, get out your note spiral and a pen or pencil so you can take notes as this video goes. We are going to start by talking about negative exponents. Negative exponents, when you see the negative sign, that means you're going to do the reciprocal of the base. So hopefully you're looking at that word reciprocal and you're starting to think, I've heard that word before. I know that word has something to do with fractions. So remember, reciprocal is when you flip a fraction. So the reciprocal of 2 would be 1/2. The reciprocal of -4 would be -1/4. The reciprocal of 3/2 would be 2/3. So remember, that negative sign means you're taking the reciprocal of the base. You still have to take it to the power. The negative sign tells you reciprocal. So here I have 2 raised to the -3 power. I see that negative sign and right away I know that I'm going to be taking the reciprocal of my base. So the very first thing I'm going to do is change my 2 to the reciprocal of 2. The reciprocal of 2 is, of course, 1/2. So it gets me 1/2 raised to the 3rd power. And now, I already know how to apply an exponent to a fraction. I'd done that a couple days ago, way back in quotient rule or quotient property. So I know that 1/2 to the 3rd power is equal to 1 to the 3rd power over 2 to the 3rd power. And I know that 1 raised to any power is just 1, because no matter how many times you multiply 1 by 1, you still get 1. So that means that this is equal to 1 over 2 to the 3rd power, which is my answer. Notice, even though I had a negative exponent, it didn't cause anything in my problem to become negative. That's because the negative in the exponent means that you're going to take the reciprocal of the base. Remember, that negative in the exponent means you take the reciprocal of the base. I'd like you to please pause the video and on your own try this problem, x raised to the -4th. Please pause the video and try this problem on your own. So I see that negative sign, and I remember that the negative sign means I'm going to take the reciprocal of the base. The reciprocal of x is 1 over x. I just flip it. And I'm still raising this to the 4th power. Again, I know how to apply a power to a fraction. I apply it to the numerator and the denominator. So I get 1 to the 4th over x to the 4th. And I know that 1 to the 4th is just 1, so I end up with 1 over x to the 4th. So you're probably wondering, Mr. Sproul, we have these new fancy negative exponents. Do they still follow the same rules that our other exponents use? Can I still use the product property? Can I still use the quotient property? Can I still use the power property? And the answer is yes. Negative exponents behave just like any other exponent. We just have to remember that that negative sign means that we're going to take the reciprocal of the base. So we can still use our product property, we can still use our quotient property, we can still use our power property. Those all work with negative exponents. So let's look at an example of using negative exponents with some of our properties. I have x raised to the negative 7th times x raised to the 4th. I have the same base. My base is x. Since I have the same base and I'm multiplying, that means I'm going to add my exponents. So negative 7 plus 4 is equal to negative 3. So it means that x to the negative 7 times x to the 4th is equal to x raised to the negative 3 power. So I have x to the negative 3 power. I see that negative sign, and that tells me that I'm going to take the reciprocal of the base. My base is x. The reciprocal of x is 1 over x. This gives me 1 over x raised to the 3rd power, which is equal to 1 over x to the 3rd power, or my final answer. Here I have another expression involving negative exponents. I have x raised to the 4th power over x raised to the negative 7th power. Since I have a fraction means division, which means I'm going to use the quotient property. The quotient property says that when I'm dividing two exponents with the same base, I'm going to subtract their powers. So I need to make sure that I identify their powers correctly. So I have 4 and negative 7. 4 minus negative 7. That's the same thing as 4 plus 7. We use skip, change, change. So we get 4 plus 7, which is 11. So that means x over 4 divided by x raised to the power of 4 over x raised to the power of negative 7 is equal to x raised to the 11th. So notice my rules about adding positive and negative numbers still apply. My exponent rules still apply. The only additional thing I need to remember comes near the end, where I have to change my base to the reciprocal when it has a negative sign. So we've talked about positive exponents. We've talked about negative exponents. Now let's talk about 0 as an exponent or power. Anything raised to the power of 0 is equal to 1. Please make sure you get this in your notes. You might need to pause the video. But you need to know anything raised to the power of 0 is equal to 1. I'm going to move on now, so if you need to copy this down, pause the video. For example, here I have 14 raised to the 0 power. I know anything raised to the 0 power is equal to 1, so 14 raised to the 0 power is indeed equal to 1. Here I have x to the 5th times x to the negative 5th. I'm going to use my product property since I'm multiplying two exponents with the same base. The product property says I should add the exponents. 5 plus negative 5 is equal to 0. So I get x raised to the 0 power. I know anything raised to the 0 power is equal to 1.